Okay, so today's question is find the kth bit in nth binary string. So given two positive integers n and k, the binary string Sn is formed as follows. S1 is equal to 0, it's already given, and then S of I is equal to S of I minus 1 plus 1 plus a reverse of invert of Si I minus 1. So here you will see both C S of I minus 1, it is also Si of I minus 1, but done some changes, inverted and reverse, but the length is same. So in any of the string, 1 is always at the middle when plused into the concatenation and reverse of x. Okay, and invert means they have just inverted the bits. So we have to return the kth bit in S of n. It is guaranteed that k is valid for the given. So what I told, the 1 will be always in the middle of any of the string except the first one. Okay, so let's try to code this. Suppose if we got n is equal to 1, so it is already given. If n is equal to 1, you have to simply return 0. Now you calculate the mid one. So mid is nothing but the 2 power n minus 1. So if k is equal to mid, that means mid 1 is always 1, so we will simply return 1. Other case, suppose if k is less than mid, if k is less than mid, so if k is less than mid, if you will see this formula, so on the left side of 1 is S of I minus 1. So our means bit lies here, so simply return, call the recursive functions, so dot find kth bit and search in the left half, and minus 1 means S of n minus 1, this is S of I minus 1, we will search here, and k will be k. Now suppose if it is greater than k is greater than mid, so our answer lies in this half. This is nothing but also S of I minus 1, but it is reversed. Okay, reverse and inverted, we will take inverted afterwards in consideration, but this is reverse. Okay, so suppose if index of a bit is 1 here, then from the right it will be n minus 1. So simply let's try to get that index. So mirrored will be the index which we are searching for. It will be nothing but 2 power n minus k, and now we have got our value, that particular index in S of I minus 1. So simply get the bit value by calling recursive function self dot find kth bit, calling n minus 1, but here now k has become this mirrored, and now simply return what we will return 1 as it is inverted. So return 1 if bit is equal to 0. As it is inverted, that's why bit is 0, we are returning 1, else return 0, not return here, else 0. Now try to run and check if this works. Okay, so test cases has passed. Let's try to submit and check. Yeah, so our code has passed successfully. Thank you for watching.